In this video, we're going to be looking at geometric progression. So this is the first video in some series of videos that I'll make. So this is a 2023 paper 2 question 3b. It reads, the nth term of geometric progression is given by 180 open brackets 1 over 2 close brackets to power n. Then we've been asked to say find the first three terms, find the common ratio, then find sum to infinity of the progression. So this was the question. So if we can observe, we have been given the nth term. We know there is a formula to find a term, which is Tn equals A times R, which is to the power n minus 1. That formula exists and it is true. But in this case, we have been given a formula to use in order to find a term of our choice. So this is the formula which we are going to use. So let's go ahead and use this formula and to answer the questions that follow. Alright, so here we go, solution. So we have been told we are supposed to use this formula to find the number of terms. Okay, so that is the formula we're using. So since we are saying first three terms for question 1, we're going to say T1, meaning we have replaced this n with a 1. So we do the same on the other side. So if you put 1 there, then we're going to yield 180. Then 1 will not change this value. It will still be the same. Then from there, we have 180 times the top number over 2, which is just 180 over 2. Then 2 into 1, it can't. Oh, yes. Then 2 into 18, it will be 9. Then 2 into 0, it is still 0. So this gives us our first term, or T1, which we're going to put here. T1 equals 90. So that we can create space to solve for the other terms. Okay, so we go now for T2. So the idea is just to change this n. Then we have this. So we change there to a 2. Then we're going to have this. Then 1 power 2 means 1. So 1 power 2 means 1 times 1. Then there's also 2 power 2, which will mean 2 times 2. This is 1, this is 4. So this will be useful. At this point, we have 1 over 4. Then this is 180 times 1 over 4. From there, this is just 180 over 4. Then 4 can go into 16 4 times, remainder a 2. Then this is a 20. So 4 into 20, it is 5. Hence we are going to yield our T2 as 45. So that is how we can yield our T2 as 45. Okay, let's go ahead and find the third term. I know from here we can find the third term, but let's use the formula as instructed. So T3 equals 180 1 over 2 power 3. Then this is 180. Then 1 power 3 means 1 times 1 times 1, which is still 1. Then below here we have got 2 power 3. So 2 power 3 means the 2 multiplies itself 3 times. 2 times 2, it's 4. 4 times 2, 8. So we've got 1 over 8, which is 1 over 8 from the previous calculations. We know 1 will not change anything. Then 8 can go into 16. 8 can go into 16, which is 2 times. Then there will be a remainder. From 16 to 18, there will be a remainder of 2, which we are going to say it's 20. Then 8 into 20, again it can only go there 2 times. Then from 16 to 20, there's a difference of 4, which is 4 over 8. Then from our mathematics, 4 over 8 is the same as 1 over 2, because we can divide a 4 there, we can also divide a 4 there to give us 1 over 2. 1 over 2 is simply 0.5, so it's 22.5 as our T3. So that's how we held T3 as 22.5. So from there, we can summarize or present our answer. We can just say, therefore, T1 equals 90, T2 equals 45, and T3 equals 22.5. The first 3 terms of the progression. So that's how we can find the first 3 terms of the progression. So now let's go ahead and find the second question, which is saying the common ratio. So for the common ratio, which is R. Common ratio, this is a number which you multiply to every term in order to go to the next term in a GP. So that is a common ratio. So it's like they're asking you, what number did you multiply to 90 for you to go to 45? Again, what number did you multiply to 45 for you to go to 2.5? So that is the common ratio. But there is a formula which has been analyzed, which is said the term in front divided by the immediate behind term. So that is how we find the common ratio. The term in front divided by the immediate behind term. So I can get advantage of, I can take advantage of T2 divided by T1. I know it's the same as saying T3 divided by T2. As long as I pick the term in front divided by the immediate behind term, the answers will always be the same. So for T2 we have got 45, and then T1 we have got 90. So we know that 90 and 45 are related in such a way that 45 into 45 is 1, then 45 into 90 it is 2. Therefore R, the common ratio, equals 1 over 2. So that is how we can find our common ratio. So in our idea here, R is 1 over 2. Okay, let's go ahead and find the sum to infinity of the progression. Okay, so the sum to infinity of a progression can only be found if your R is less than 1. The sum to infinity of your progression can only be found if your R is less than 1. So here is the formula. Sum to infinity, that is the formula, equals A over 1 minus R. So for sure you can see that it can only happen if 1 is less than what? R. If R is less than 1, that's when this sum to infinity can be calculated. Okay, from our data, A, which is T1, is equal to 90. Then what else do we need from the formula? 1 is a constant, so we need R. R